Hello, welcome back to a new episode of For the Love of Weather. This is the podcast where we explore the Earth's atmosphere and how we are all connected through the weather and climate. We are your hosts, Gemma and Aisling, both meteorologists and weather presenters, and have been working in weather now for over 15 years. If you're new to the podcast, we are so happy to have you here with us today. And if you are coming back to us, it's amazing to know that we have your company again. And as always, we just hope that you leave this episode loving the weather just a little bit more, and you learn a little something about how the weather and climate can impact your daily lives. I'm Gemma.
Hello, and I'm Aisling, and today we are here with Krista Hammond, who I am a mega fan of, both in personal and professional work, may I just add. But she's a senior account manager for space weather at the Met Office, and that is what we are here to talk about today. But I'm just going to give you a quick whiz through of what she's been up to for about 16 years now. So, an operational space weather meteorologist, you're an account manager as well. You've done aviation forecasting, detachments, environmental monitoring, response, and you've also sat on a panel in fall American Geophysical Union.
Yeah, American
That right?
Geophysical Union. Yeah, that's right. One
Yeah.
of their meetings back in 2019. Yeah.
Yeah. And you've done loads of stuff. You've just been recently over there talking about space weather again, haven't you?
Yeah, just even in January, I was over at Baltimore as part of the AMS, American Meteorological Society meeting. So AMS is a big meeting for all the sort of meteorology world, but it also includes a conference on space weather as well. So I was over there talking about the work that we do in the Met Office for space weather for aviation in particular. Yeah, it was a
Just
great opportunity.
absolutely love watching what you do. But also, while you're not doing that, you're also just being an absolute legend in the gym, may I add. If you don't know her, go and find her Instagram account. She's absolutely amazing. But anyway, without further ado, always start by asking our guests, Krista, when was that moment for you where you're like, I think I might be a scientist?
Oh, well, thinking about it, I've always been interested in how the world works. I sort of remember being a kid and always being like really interested in nature and just the whole world. Like loved learning about volcanoes and earthquakes and space and how things work. Always like to learn things, and I think that's really like where it started. It's just wanting to understand how the world works. And yeah, I was really into sort of science at school. It was into physics and geography, and it just kind of went from there. And it's I did geoscience at university. It wasn't meteorology that I went into, and it's just like this constant desire to learn more. I think because that's what kind of when I finished uni led me to apply to be a meteorologist. Saw the advert, thought that sounds awesome. Let's find out how the weather works, and then it kind of just escalated, and I ended up in space weather. So it's it's been quite the meandering career path actually.
That's what the Met Office offers, though. It's a fantastic place to. Oh my God, there's so much on offer there, so much on offer. But tell us, what's space weather?
Yeah, well, space weather is probably one of the lesser known areas of forecasting that we do at the Met Office because we do actually forecast for it. So, space weather itself it describes the changing conditions in space. And to understand that, we have to look at the sun's activity. So, solar flares, radiation storms, eruptions of plasma that we call coronal mass ejections, they all cause like changing conditions in space, which can cause disturbances in the near Earth environment. So by that, we mean the Earth's magnetic field, the Earth's upper atmosphere. So it's these disturbances, it's the sun's activity that we refer to as space weather. And the reason we do it at the Met Office is that that can have an impact on our technology and our infrastructure here on Earth.
How are you monitoring all that stuff? That's a lot of stuff to be keeping an eye on. How are you monitoring all that?
Yeah, so it's kind of similar to weather forecasting. We've got a position, a bench at the operations centre, which is the Met Office Space Weather Operations Centre, and it is a forecaster there specialising in space weather forecasting, and they monitor the sun 24/7. So to do that, we've got satellites. We use satellite imagery to look at the sun. If you've ever seen the bench at Moswalk, they've got computer screens up which have got multicolor pictures of the sun, and what that is, it's imagery which is looking at the sun in different wavelengths, and by doing that we can look at different features. So space weather typically originates from sunspots, so some of the imagery will be showing sunspots as we would view it just in sort of white light and normal light, but we're also looking at things like the magnetic field. We're looking to see, if we look in extreme ultraviolet, we can see if there's been solar flares. We can look at sort of the magnetic structure of the sunspots and the things like this. So by doing that, we can get an idea of kind of similar to weather forecasting. You've got observations where you're looking at, if you look at satellite imagery, you can look at weather systems, and then from that you can sort of work out where things are going to go. We do that, but with the sun. And instead of high pressure or low pressure, we're looking at sunspots, and we're looking at the magnetic field and plasma. It's a lot of observation, and we're there all the time. It's just another bench in the operations center in Exeter.
So I think space weather, so it's evolved loads, like even since I started my career. But we all see space weather, and actually people probably don't realize when they're looking at the aurora, or maybe they do, but they think, oh, that's really pretty. It's really pretty. And sometimes it is fun, like it is phenomenally pretty. But really, why should we care? Why should we care about space weather? What's going on? Like, why does that bench there?
Yeah, that's a good point. So yeah, space weather, we don't normally see the impacts of space weather. It's changes in magnetic field. You don't normally see that. But the aurora, the northern lights, that is space weather, and it's a sign of a geomagnetic storm. And this is when the sun has released this sort of bubble of plasma. I say bubble, this is billions of tons worth of charged material that is ejected into space. The scales of space weather are mind-blowing if you come from a Met background. So that's ejected into space, and it's the interaction of that energy with the Earth's magnetic field and sort of some chemical reactions down the line, which cause the aurora, which, as you say, is absolutely beautiful. Apparently, I've not seen it, which is scandalous being from the north of Scotland. It's very common in high latitudes. It's there almost all the time in polar regions. And it's a sign of a geomagnetic storm. It's space weather that's arrived at Earth and is causing these disturbances in the upper atmosphere. And most of the time, that's quite a mild disturbance, in the same way that weather occurs all the time. There's wind all the time. There might be fog, there might be mist. It's not hazardous. It's when we get the severe space weather, so severe geomagnetic storms, that's when you can see the aurora further south. And it's also a sign that there might be quite, a much stronger geomagnetic storm occurring. And as well as causing the aurora, it can then also cause impacts on our technology. So the same feature, which is causing the aurora, can also cause changes to layers of the Earth's atmosphere, particularly the ionosphere, the areas which like satellites orbit in, and it can cause problems with communication systems, and it can disrupt satellite orbits. And we're so heavily reliant on space-based technology now that any of sort of the disturbances to that causes impact to us on Earth.
So I have so many more questions, but I was just wondering if you can explain something to me, right? Can you tell us a little bit about how you can permanently look at the sun? Can you talk about the Lagrangian points for us?
Yeah, let me try and explain this. So there's a couple of ways that we are always looking at the sun, and as I said, we have satellites which are constantly trained on the sun. Most of they're in front of the Earth on the sun-Earth line, but the Lagrange points is a good one. So one of the positions that we use to monitor the sun is Lagrange 1, L1, and it is almost in perfect gravitational balance between the Earth and the sun. So it's 1 million miles away from Earth and 92 million miles away from the sun. And at this point here, you can put a satellite there and it will stay more or less in the same point, so that as we orbit the sun, the satellite can quite easily sort of follow with us, and it will constantly be trained on the sun. So we've got that always like the line of sight view of the sun from there. The reason Lagrange points are interesting is that there isn't just one Lagrange point in the solar system around the sun. So that one's L1, that's in front of the Earth looking at the sun. One which is really interesting to us as space weather forecasters is the Lagrange 5 point. And it would give us a side-on view of the sun-Earth line. So instead of looking straight on at the sun, we'd be looking at as something was to leave the sun, we'd be looking at the sort of the line from the sun to the Earth. And this is super helpful in space weather forecasting. When we're looking at the sun using, just from the Earth, if we're looking for a coronal mass ejection, this eruption of plasma from the sun, we see it as almost like a halo of material leaving the sun. And if we see that, then we know that it's either going directly towards us or directly away from us. It looks the same. Now, we can establish whether that's actually coming towards us, space weather like that typically originates from sunspots and solar flares, and we would see that on the sun. So if we saw a bright solar flare on the Earth-facing side of the sun, and then we saw this halo come out from it, we could establish that was a CME that's Earth-directed. But if we have this side-on view so that we can also see that Sun-Earth line from the side, we can see that material as it leaves the sun, and we can very quickly establish, yep, that's Earth directed. But then we can also see if a lot of it's going to go to the south of the Earth, or if it's going to go to the north. Is most of that material going to hit us? Is it going to miss us? And it gives us sort of an extra side-on view. Now, we don't have a satellite in that position at the moment. There was one there a little while ago. There was a satellite mission. It was a science mission, and it's called Stereo. And it was a NASA mission, and it sent a satellite ahead of the Earth's orbit and one behind. And it went around the sun to sort of take footage of the sun. And what we found out was when that came back round into that L5 position, it was extremely useful for space weather forecasting. So the European Space Agency is actually going to launch a mission towards the end of this decade called Vigil, and it's going to that L5 position, and it'll stay there because the problem with the stereo missions was they were never designed to stay in one position. They were designed to keep going around the sun. Vigil is going to stay in that L5 position, and it'll be an operational space weather forecasting mission so that we've got that constant side-on view of the sun as well.
Like
so awesome.
Me, I can feel the both of us, Gem. I know when we're listening to a podcast, we're like, what? Tell me more. My brain is like fizzy with excitement.
So do all the agencies use the same information, and do you like communicate with each other when it comes to putting information out and making decisions?
Yeah, we do. So because it's a lot of what we use to observe the sun through satellite imagery, is through satellite imagery. A lot of that is pretty much owned by NASA. So it's all available. And to draw another parallel with weather forecasting, and you'll know this from having a Met background. When you're doing a weather forecast, you have so many observations to verify your forecast. Not least the public, but weather stations. I think you underestimate like how many weather stations there are even in the UK. There's hundreds. We don't have that in space weather. We've got a handful of satellites which we're using to observe the sun, and they're used by other agencies like around the world. International collaboration is really big in space weather. It's an evolving science. We're behind where we are with meteorological forecasting, but there's always research going on across the globe. There's real effort to understand more from the physics of the sun to then how we use that science to pull that into operational forecasts. So agencies around the world were using a lot of the same data, particularly with when it comes to satellite data, and we're sharing information. From when MOSWOC was set up, we've worked very closely with the United States. The Space Weather Prediction Center over there has been on the go for a lot longer than we have. We're 10 years of operational forecasting in the UK, and I think there's something like 50 in the region of that. So we've always had this sort of close US-UK relationship. And there's other countries around the world, as different countries are sort of realizing the threat of space weather. We're seeing more operational centers being set up. So, we work with other institutes in Europe, and the likes of Australia have got a space weather prediction center. And it's a global threat. So when you have, something on the scale of space weather, I say that a coronal mass ejection is billions of tons of plasma. It's affecting the Earth's magnetic field. It's not affecting a local area. It can affect a hemisphere. So it's a global problem. So we're kind of working globally to come up with solutions with it as well, and sort of share our knowledge.
And that's because there's so much satellites now dictate time and banking and all that sort of stuff, isn't it? It's because of almost needing to know more about it is because we are so advanced in our technology. Is that right?
Yeah, that's right. So it's like you're saying, it's this advancement in technology and the fact that a lot of the technology that we rely on, satellite technology, can get impacted by severe space weather. So if we were to get like one of the most severe space weather storms, for example, GPS could be disrupted or lost for days at a time. And a lot of our technology is now relying on GPS for position, for navigation, and timing. And there's so many electronic systems which are reliant on that. globally, that it would have a big impact. It's worth saying that space weather does happen like all the time. You do see the aurora across northern latitudes loads. It is the most severe cases, though, that we're interested in, because those are the ones which will cause the biggest impacts on Earth.
How often do those big events happen? Like, when was the last one?
Oh, it's been quite quiet in space weather. So how about it's sort of I quickly give you sort of an idea of why it's been quite quiet. The sun's got a cycle of activity, so it's not constant. It runs in a roughly 11-year cycle called, well, the solar cycle, and it goes from solar maximum to solar minimum and back to solar maximum. Solar maximum is when we have the most sunspots. Solar minimum is when we've got the fewest, and we can go days at a time without seeing any sunspots. And that cycle is roughly 11 years from solar minimum through to solar maximum back to solar min. So the last solar minimum was in 2019. And also, most of our space weather originates from sunspots as well. So it follows that the more sunspots we have, the more space weather we have as well. So the last solar minimum was in 2019, and the solar maximum is forecast to be any time from now. During 2024 is when the solar maximum is due to occur. So we have a bit of a lull, during solar minimum, because you tend to get fewer space weather events then. So that's one of the reasons why it has been relatively quiet, and now we're starting to see an increase in space weather. But the other thing is, although that sort of dictates the frequency of space weather events, it doesn't tell you the magnitude of them, and it's the more severe events which are of a concern. So for this, we haven't had sort of the highest magnitude space weather event in probably about 20 years, some of which is actually luck. During the last solar cycle in 2012, I always found this really, really quite interesting. This was just as Moswalk was being set up as a center. There was an enormous coronal mass ejection that came off the sun, and the sunspot was facing away from the Earth. So this, all this charged matter was ejected into space, and it was a huge coronal mass ejection, and it missed the Earth. And it's basically just by luck, because 10 days earlier, that same sunspot had been facing the Earth. So if that had been released then, that would have been a really quite significant space weather event. When it comes to planning, for the most severe space weather events, we'll use sort of examples of 1 in 50 years, 1 in 100-year events. The 1 in 100-year event is what the UK governments and critical sectors use as a reasonable worst case scenario for emergency planning. So that's based on an event which happened back in 1859, known as the Carrington event. So yeah, those are the really severe events we consider to be sort of that we use for planning are 1 in 100. But yeah, it varies massively, and sometimes just by luck.
So the last solar minimum was 2019, but it's only 5 years later now. And you were saying a solar cycle is 11 years. So how long does a maximum cycle last for?
Yeah, so the cycle goes from minimum to maximum to minimum.
Oh, so you're like constantly at inflection points.
Yeah, that's right. That's
Yeah.
right. So then you got to solar maximum, and then you go back to solar min. Being at solar maximum, though, is not sort of the guarantee that's when you're going to get the significant space weather events, and being at solar minimum doesn't mean you're going to get none. Historically, severe space weather can occur at any point in the cycle. It's more likely to be away from solar minimum just because there's fewer sunspots at solar minimum, but just because the events are more frequent, it doesn't mean that they'll necessarily be more severe.
Yeah.
Is that
Yeah.
why it's going to be quite a good year this year if you want to see the Northern Lights, because we're heading towards the maximum? Is that why? Do I need to book a trip to like Iceland or something?
Yeah, that is the thing, because the more frequent space weather events we get, the more of this geomagnetic storming that we'll have. That's what's driving the aurora. Yeah, and so especially when we had solar minimum, suddenly there's a lot more reports of space weather. I think cameras getting better so that you can actually record them easier on your phone as well has probably helped substantially. But yeah, as we go into solar maximum, the chances of seeing the aurora is increasing as well.
Can you tell us the difference between a CME, a solar flare, and what was the other one?
Oh, radiation storm. Yeah. So
Radiation storm.
those are the three main types of space weather. The three main types that we're looking at are solar flares, solar radiation storms, and coronal mass ejections. So yeah, it's kind of important, especially for the industries which are affected by space weather, to understand the difference, because they've got different sort of physics behind them, different forecasting skills that, we've got different forecasting skills for them and so on. So solar flares, to start with, these are we view these as bright flashes of light on the sun, and these are eruptions of electromagnetic energy. So they travel at the speed of light. They arrive at the Earth about 8 minutes after they've occurred on the sun. Yeah, so we see these are like electromagnetic energy pulses that we see. At the same time, we might get a solar radiation storm as well. So solar radiation storms, it's high energy charged particles, predominantly protons. These are released about the same time as a solar flare, but they travel slower because protons are not traveling at the speed of light. So they arrive after the impacts from the solar flare. So that can arrive like minutes to hours after we see a solar flare on the sun. Coronal mass ejections, this all can happen at roughly the same time, by the way. So if we look at a solar flare, that's what we see initially, and then we're looking to see if there's been this release of plasma at the same time as the solar flare. So the plasma it's got mass to it, so it's slower again, traveling through the space between sun and Earth. It still travels pretty fast. Like the speeds when we talk about space weather, and the magnitudes are so just, again, when you first move into space weather, it's mind blowing. So a slow solar wind is about 400 kilometers per second. A coronal mass ejection is moving at thousands of kilometers per second, but it has 140 million kilometers to travel before it gets to the Earth. So the fastest CMEs will arrive in the sort of Earth space sort of between around about 15 to 20 hours after it's released from the sun, and the slowest of, you're talking days for it to get here. And it's kind of important to know, because like when we're talking about solar flares, they originate from sunspots, and our forecasters can look at the sunspots. They can see that they're quite complex. They can see that they've maybe flared already. They've got complex magnetic field, so there's a chance that we might see some solar flares. But because when they occur, the impacts are being felt here on Earth pretty much. There's only so much warning that you can give that we're going to get impacts from a solar flare. Whereas when we see a coronal mass ejection leave the sun, because it then takes a day or so to arrive at the Earth, it means our forecasters can analyze that, put them into computer models, which can establish whether it's coming towards Earth, and if it is, when it's going to arrive, which means we've got some kind of forecast ability to warn sectors, government, that we've got a potential disruptive space weather event coming.
That is fascinating.
It's crazy. It's really crazy as well when you see the images of the sun, because sometimes I have to look at them if I'm looking at the aurora. And then when you see like these CMEs coming off, you just think it's astonishing when you actually think about that coming out of the sun and then coming towards us. The images are amazing.
They are. It's great to put like a little dot on to be about the size of the Earth would be, just for a bit of perspective as well. Yeah, because the scale of these events is enormous, isn't it? It's just this huge. We call them bubbles of plasma. It's like, oh, it's a big bubble of plasma. You're like, yeah, billions of tons of charged material.
It's just mad. I mean, and it's a kind of, on a more philosophical note, it's a minor miracle. Like, how are we here?
When I was at
it's mad.
AMS, I actually thought about this. There was a presentation, I think it was from someone at NASA, talking about one of the missions that they're putting up to that Lagrange 1 point, actually, where they're putting the satellites which are there at the moment are aging. So there's now a mission that I think it's NOAA that are putting up to replace that satellite there at L1. And I think it was someone from NASA who had like an image of the satellites that we've got, the satellites that are coming, and just that, all this that we do to monitor the sun. And yeah, I had a moment, like I had a proper philosophical moment. I'm like, wow, the one thing which is actually keeping us all alive here on Earth at any point could just release this massive solar storm that could, cause serious issues with our technology. So we send these tiny little satellites into space so that we can keep an eye on it.
In terms of those satellites, where exactly, like, how far away from the sun do they sit? It's probably a really random question, but how far away from the sun are those positioned?
It depends. It depends on the satellites. So the satellite which is sat at the L1 point, which is giving us this view of the sun like face on, it's 1 million miles away from us and 92 million miles away from the sun. We also have satellites which are sort of much closer to Earth at geostationary orbit. So actually they're geosynchronous, so it's always looking at the sun. And it's very close to Earth. So there aren't really any which are particularly close to the sun. There are a few missions at the moment which are science missions to try and understand more about the physics of the sun. So there's Solar Orbiter, which is getting closer and closer to the sun. I'm trying to remember when it was launched, and I can't remember. But essentially, it was it's been launched on an orbit that just gets closer and closer, and it's seen parts of the sun which haven't been seen before. But the majority of the satellites that we're using for space weather forecasting, the operational stuff, there's that L1 point, and there's satellites near Earth.
What do you think the public knowledge is of space weather forecasting? Do you think they realize? Do you think they connect aurora, and do you think that they connect other things? Like how much more public interest have you seen since you started, or like as a trend, since the Space Weather Centre started?
Certainly starting to see a lot more. Especially sort of as we've been coming towards solar maximum. And one of the things that we're trying to do at the Met Office is more in the way of sort of public outreach, education pieces and so on, because I think the understanding of space weather in the general public is really quite low. It's easy when you're in the space weather fields to forget quite how mind-blowing what we do is. And I think that using the northern lights, using that to say this is what space weather is, and then leading on from there as to why it's kind of important that we forecast it, is a good way in. Is a good way to sort of get the public's engagement. And the likes of you on the sort of broadcast Met side, certainly seeing more of an interest in that and an understanding of like explaining to the public what it is and how it works and things like this, because I do think that the understanding generally is quite low.
So, Krista, tell us, you were talking about the ionosphere. So that's nothing to do with where we have the day-to-day weather. So do you want to just talk us a little bit through the building blocks of the atmosphere? So, we're from the bit with the weather upwards. Just explain where that is.
Yeah, sure. So the ionosphere is part of the Earth's upper atmosphere. So whereas our meteorological weather, our day-to-day weather, occurs in the troposphere, which is the lowest part of the atmosphere, it's many layers above that. So it's above the troposphere, it's above the stratosphere, it's up towards sort of the thermosphere area, and it's this layer of the Earth's upper atmosphere where X-rays from the sun, solar radiation, can ionize the atoms in that area, which means that this is the area which space weather is able to impact the most. So it's the upper layers of the Earth's atmosphere.
It's kind of mad, actually, that, in that upper part, which about 100 kilometers or so is 120 kilometers or so, if you imagine, that's how far we can see. Do you know what I mean? Like you can see up that high into outer space. It's a bit mad.
From quite far away, because that's the area where space weather is impacting the ionosphere. This is where we're seeing the aurora, and you can see it so far south of where it is as well. Looking into space almost.
And then the most basic of thing, like a cloud, stops us from seeing that. It's just mad. I just think it's
rid of it.
What do you get clouds
and
here?
if the moon's too bright, you can't see it properly.
Yeah.
If you've got a full moon, not now moon, it's, things can just block it, and you're essentially just looking into space.
Incredible.
I'm interested to know, does the 11-year sunspot cycle, does that have an impact on our climate?
It has got absolutely minimal impact on sort of the climate and global temperatures. There's very little interaction between space weather and meteorology as we have it. And when it comes to sort of temperature change across the 11-year cycles, studies have shown that it's sort of in the region of about 0.05 Celsius difference, sort of global temperature. So it's essentially insignificant. Since the Industrial Revolution, global temperatures have risen by 1.1 degrees. So 0.05 pales into insignificance.
Okay, so we're going to move on now to our get to know me round. Some of these are weather related, and then some of them are just super random. So we always start by asking our guests what their favourite season is.
Oh, summer. Love summer. Yeah. Long days, heat. There's a reason I now live in the south of England and not the north of Scotland. Yeah, summer baby through and through.
Not many
That's
people say
interesting.
summer.
Yeah, no, because and you know what, that is interesting because most people say spring or autumn because they love the change, but that is the change is complete at that point. That's really interesting.
Yeah, I do like spring because it means summer's on the way. But it's
Yeah, good short answer.
it's the appetizer for summer. The amuse bouche.
Yeah,
Bring on the summer.
a little starter.
But then occasionally, you get that, and then you'll get a beast from the east. You're like, great, it's winter
I
again.
know.
So
Yeah,
no,
like it's
summer.
April. Why are you snowing? It's like because statistically, it's more likely to happen around Easter time.
If you had to choose, would you prefer the beach or the mountains?
Oh, beach through and through. You can tell, like, basically, I'd just like to spend my entire time in the summer by the beach. Mountains are beautiful, but I love being by the sea. I love the sea air. I love the sand. I love swimming, everything.
So calming being by the sea, especially if you've got a lovely sunset. You can't beat a coastal sunset. They're just so beautiful.
Oh, can't wait. That's heaven.
I'm interested to know, do you have a favourite cloud?
Oh, always. I mean, what meteorologist doesn't? I love the noctilucent clouds. They're my favorite. I saw them in Aberdeen once, and they're just absolutely stunning. There are nacreous clouds. They're also very pretty.
It's a tough one, isn't it? They're both incredibly pretty. Although we did chat to Dr. Simon Lee about the dark side of nacreous clouds.
Mm.
So that was worrying. I was like, oh,
Yeah,
there's a
yeah,
lot more chemical stuff going on up there than I realized.
that's it, isn't
Yeah.
it? Yeah, you just think, oh, they're so beautiful, and then you read into it, and it's like, oh,
Yeah.
that's not great.
However, let's stick with the beauty. Totally agree. They're very beautiful and not rare because everyone has cameras now, but like rare enough that it stops you in your tracks when you're like, oh, look at
Do
that.
you know another cloud which I really like? Oh, we're going to now talk about clouds for 20 minutes, aren't we?
Yeah.
I just love a good lenticular cloud.
Me too.
Yeah,
Yeah.
Yeah.
we're going to take a bit of a pivot now. If you could have a superpower, what would it be?
That is a pivot. If I had a superpower, I think it would probably be the ability to fly. That would be pretty cool, just for sort of ease of getting around, as for one thing. But also, yeah, pretty cool to fly amongst the clouds. That would be pretty sweet.
Okay, if you were a fruit or vegetable, what would you be?
These are so left field. I love it. Pineapple.
Oh, hi.
I don't know. It's tropical. It's
Ah.
nice. Makes you think of holidays. I like holidays. Yeah.
I,
Yeah.
I I always just I say this every podcast, but I just find it so fascinating how people actually identify with a fruit or a vegetable. Like nobody thinks too long about it, and they're like, I want to be that. They want to
I
like
sort of
it's
in my head
mad.
there went definitely not an apple, not a banana, not a pear, pineapple. Clearly.
Yeah,
Yeah. Yeah.
fruity, sweet, pleasurable, yummy.
It reminds you of summer as well.
Summer,
It's that summer. Yeah. It's all back to that.
versatile.
Yeah. Yeah.
And so our final question is, what is one thing that you wish everybody knew about space weather?
I think when it came to space weather, it would probably be just the impact that it can actually have. Earlier we sort of said that I don't think there's much of a public understanding of space weather, about the aurora. I think that it would just be to understand that when we have severe space weather, we would notice the impacts here on Earth, or certainly the industries which are using technology which can get impacted by space weather. I think, yeah, in short, it would just be kind of the importance of it, like why we do it, like why it's important is what I would want them to know.
Krista, thank you so much for joining us tonight. Another just amazing podcast, so much information, and I can't wait to see what happens next with space weather. It's pretty incredible how far it's come in such a short space of time. Hopefully we'll have you on again soon.
Thank you so much for having me on. Yeah, and anytime, it'd be great to come back.
If you have listened to this episode and you have enjoyed it, we would love it if you subscribe, rate, and review the podcast. It really helps other people find our podcast. And also, if you really enjoyed this episode, then share it with all your friends. If you'd like to follow us on Instagram, we are For the Love of Weather. On X, formerly Twitter, we are the #4 Love of Weather. And Krista, if people want to keep up to date with the Met Office and the space weather, where can they go to?
If you follow us on X at Met Office Space, you'll get the space weather information on there, and Met Office for the main account on X.
Brilliant. And as always, we just hope that you leave this episode loving the weather just that little bit more.
Thanks for listening. Bye.